Hello and welcome to this course on AI agents. I'm calling this lecture Programming GPTs simply because I will be leveraging the OpenAI ChatGPT API in order to implement some of the examples that you will see in this lecture. Right, so let's start with a simple demo of an app that I've developed. That is implementing an AI agent called Thomas. So Thomas is a travel agent at a company, a travel agency called Vanderlust. So this is fictive. It's inspired from a demo that has been done by OpenAI at the Dev Day in 2023. And this agent has the ability to help you plan your trip. You can ask about a location, and it can point you to interesting sites on the map. So let's see how Thomas is leveraging those tools. So let's ask him, hey, can you point me to the top sites in Paris? So as you can see, the agent is using functions, update map and add marker, and the result, once it is done, is here on the right hand side, this map that has been updated with, let's see, Eiffel Tower, Louvre, Notre Dame, Champs-Élysées, and Sacré-Cœur. If we zoom out, okay, so we do have the Eiffel Tower over here. For those of you in the audience that have visited Paris, I hope you just checked it out. This is Notre Dame. The Louvre is, yeah, it's roughly over there. But here, Sacré-Cœur is completely off. It's definitely not there. What about the Champs-Élysées? No, the Champs-Élysées is right here. So not quite there. Let's give it another shot. Maybe now in Boston. Hey, take me to Boston. So it's simply going to update the map, and here we are in Boston. Now, what about things to see in Boston? So it's going to add a few markers on the map. Here we are, the Freedom Trail, very famous for everyone that is visiting Boston, the Common, the Tea Party, Harvard. Harvard is clearly not here for, I mean, those of you in the audience, they may know that Harvard is in Cambridge, somewhere around here. So here you have MIT, and Harvard is somewhere around there. I'm not quite sure anymore. Definitely not over here. How about Fenway Stadium, the home of the Red Sox? Updating the map, adding a marker. Let's see. Not too bad, not too bad. Fenway Park, it's right around here. Okay, so let's just take a step back and try to understand what's been happening here. Essentially, I gave the AI, Thomas, some tools, and that gave the ability for this agent to perform actions. So let's take a quick look at what I mean by that. So in this lesson, I'll cover the notion of agent. We'll go into some of the underlying concepts that are necessary in order for you to derive out of a large language model out of an AI general purpose model, an agent, and how it can select tools. So there will be some about chaining, some about doing certain types of action like search to perform Q&A, for instance. But let's just take a look at a simple exercise that you can do yourself with ChatGPT. So here is a simple prompt. So this is kind of like the notion of prompt engineering, where I give first the AI some personality. I'm saying you're an agent, and you're going to access to tools to perform action. So this is the personality of the AI. For every prompt you receive, you'll decide which tool to use. And here is a list. So here I'm giving two examples. Search, useful when it's about current events. Python, if I want you to perform some computing or, for instance, solving mathematical problems. And so this is just like the prompt, but now I'm going to give it a few examples so that it can perform what is known as few-shot learnings. So it's going to learn from those two examples. Like as a user, I could ask, what movie won Best Picture in 2023? So, by the way, just quick question for the audience. Do you remember 2023? What happened? So this was a very good movie called, I think, Everything Everywhere All at Once. I would definitely recommend it. And so now, okay, the 10th element of the Fibonacci suite or sequence, for this it would use Python. Now I'm going to follow this by a question, what is the square root of 42? And now, instead of answering the answer to this question or attempting to do so, it will actually just answer to me, hey, you should use Python. And that's just a single word. That's also what I've asked the AI to do, kind of implicitly, right? I didn't tell explicitly, hey, you should just answer with one single word. But here you can infer from those two examples that that's what I wanted to do. So pretty good at following instruction. Here is another example. Who won the Oscar in 2024? Search would be the right tool for the job. All right, so based on this simple example, there's well, quite good papers that you can read about the notion of reasoning and acting, and we will see how those concepts are essentially the foundational building blocks for agents. So what is an agent? Simple definition, an agent based on a selected query is going to select a tool. So if you give it a question like I did, the agent, the AI is going to say, hey, I want to use this tool. Now, that's when it becomes a little more interesting, is what's actually happening with those agentic framework is that so you essentially program them in order to give them tools, and then what happens is that they will iterate. They will start by thinking, okay, based on the query, I'm going to start thinking about reasoning about what do I need in order to answer this question. Then I'm going to look up the list of tools that I have available, tool 1, 2, or 3, and then I'm going to create an observation, which is, okay, I'm going to need to use tool number 2. And this is a loop, this is an iteration, so once you'll be using tool number 2, you will get the result from this tool, and then you'll ask yourself again, like, do I need something more in order to continue answering this question? And so this could go on for several iterations. So that is not a single turn, essentially instruction following, but it's a slightly more complex system. Okay, so this is the foundational building block, and let's see. Let's go back to our example with Thomas and see how I've implemented it with the assistant framework from OpenAI. So OpenAI implemented this notion of assistant, and here essentially I'm creating one called Thomas, and that is the APIs that I'm using on the back end of my application, the Wanderlust application. I'm giving it a system prompt. You're a useful, helpful travel agent who has access to a map to display information. I'm assigning a model, a large language model, in this case GPT-4o mini, in order to perform all of the actions. And in terms of tools, there are some pre-built tools like the code interpreter and file search that have been already implemented by OpenAI, but here I'm going to be providing custom tools, custom functions, the update map function and the add markers. So essentially what it is doing, update map, well, let's actually look at add marker. It's simply going to add a list of markers to the map. So when I ask a question about point me to Fenway Stadium or maybe the aquarium or some other location, then it's going to be essentially creating a list of latitude and longitude elements, longitude and latitude in this order. So simply trying to also label and to provide all of those outputs. And so this is how it's performing it right now. This isn't great because in this case we are trying to use the AI as a way to predict what would be the longitude and latitude. And as you can see in some of those examples, it was not giving such a good response. So like for instance, the aquarium, let's see. Adding a marker, updating the map. Whoa, it's way off. It's right in the middle of the Boston Bay. So clearly it's not so great at doing such a thing. So that's one of the examples where you might want to be using a tool instead, like Google Maps, for instance, to search it up. But here it's trying to just guess what would be the latitude and longitude. Not completely off, but still not perfectly right. You can check out the code if you want to take a look at how this has been implemented. Here, essentially, so all of those session state are defined for my application. But here, what's more interesting is the tool setup. So there's about 250 lines of code. And then here, as you can see, there's a definition of the function to update the map with latitude, longitude, and certain zoom. Here, it's adding the marker states. So that is the function that is going to be called in order to leverage this framework from OpenAI. So since we are at tools and we had another example, so for instance here the code interpreter, you can actually see that inside of ChatGPT, those types of concepts have already been implemented. So if you ask for the Fibonacci tenth element, so here it's actually not trying to answer directly, but instead it's thinking, okay, I may need a tool for that, so let's use Python. So it's writing a function, the Fibonacci function, so it's writing the code, executing the code, and giving you back the response. So as you can see, inside of ChatGPT, there is already the notion of agent. In this case, one of those agents is the data analyst, and that is the agent, the GPT. Essentially, that's the another name in ChatGPT for those agents. They call them GPTs. You can explore the GPTs and build your own GPT, but there are a few pre-built, like the data analyst here, that is being used. So this is the notion of agent. Now let's take a few steps back to understand what you actually need in order to create your own agent. So here I've implemented a bunch of them. So here you have like a whole army of small agents, essentially, that all have their own specialty. So this is an app that you can also replicate yourself. It's well, the name of the lesson, programming gpts.streamlit.app. And I've implemented a bunch of them. So just to give you a sense as to how you'd go step by step in order to implement your own agent. You can start by creating a very small chatbot like this one. This one is simply just the replication of the ChatGPT app, and it's simply calling the ChatGPT API in the backend. So here you can say, hello, how are you? And then you can ask what is the 10th element of Fibonacci. And let's see. Yeah, it's getting it right. Okay. Starts with 0 and 1, and the first response is 1. I mean, I guess it depends when you start, because if you were to start at 0, then you'll end up with 34. But I think the definition is that you'll start at 1. That's one of those things where indexes at which a sequence is starting is probably a debate for many. So you can configure the chat to change, like for instance here I want it to be a cute little bird, little birdie is, I guess, very chatty, so that's why you could define it to be chatty. You can define which model to use. I'm still also using the old one, GPT 3.5 Turbo. You can also change the user, and here you go. You would have a conversation that is a little personalized. So you can, personalize your own chat GPT. Then once you've done that, let's go and introduce the notion of chaining. And so for that, what I'm going to do here is I'm simply going to take one of the chapter of the book that I've written, Programming GPT here, on that topic, and I'm going to try to summarize this one of the chapter. Let's just pick one of the chapter 1, for instance, and let's create a summary. And what will happen is that here, essentially, I'm going to break down the chapter into chunks. Okay, so here the overall chapter is composed out of a little over 3,000 tokens. I don't know if you guys remember what is the relationship between tokens and words in English. If you compare the English language to tokens, so I think that a token is roughly 3/4 of a word. So if you have 3,000 token, I think it's roughly around like 3/4 of this. Okay, so let's refine this. And so essentially what it's going to do here is I'm going to be looping and chaining essentially calls to a large language model in order to do subsequent summaries that I will refine gradually. And here is the results, just by breaking it down, chunking it down into small chunks, and just saying, hey, do the first summary for the first chunk and iterate. So let me show you how this breakdown is performed, and I'll just go down to the section on chaining. So chaining. So here, the very reason why I'm illustrating some of this chaining with the example of summarization is simply because that was the very first type of application that I had implemented back in March of 2023 when the ChatGPT API became publicly available. So I was spending a whole lot of time in meetings, and I figured, you know what, maybe I could simply summarize those meetings by retrieving the transcript out of Microsoft Teams and simply write a very nice summary so that I don't need to take notes myself. It's much more convenient. I can really pay attention to the meeting. But so I ended up encountering a kind of a limitation here of this system. So you need to remember that back in those days, in March of 2023, the version of GPT 3.5 that we were using was limited to 4,000 tokens. And so, well, you may say it's fine, it should be fitting, right, in the context. But remember that in my example, with the chapter 1, you already have, well, you only have about 4,000, you only have about 8,000 tokens left for the response, because the number of tokens needs to be the addition of the input and the output. So here, if you were to try to fit 4,000 tokens inside of the LLM, you would not have any space left for the response. What you can do is say, hey, you want to have a 50-50, like the prompt would be taking 50% of the space in the context window, so about 2,000 tokens, and then you would have a response that can take up to 2,000 tokens. Otherwise, you just give it a very short prompt and you try to generate a very large response. That would be the case if you want to like generate a whole essay or like a chapter of a book just by simply prompting. Or the opposite would be here, a long prompt, like a very long like chapter, like the one that I want, and then I only have a few tokens left to generate the response. And what might happen in this case is that if the response is too long, then it doesn't fit anymore, and that's it. That's the end of the conversation. So let's see if we have another example from another chapter that is slightly longer than that. Here, for instance, 4,665 tokens would be too long for the length of the window, the context window of the GPT 3.5 from back then. So you could try to stuff everything into the prompt, but in this case, if your document is longer than the system, the length of the prompt, the context window, then it would not work. And that is essentially what was happening to me when I was trying to summarize meetings. Could you, for instance, guess how many tokens represent an hour of conversation? And that's in average, right? Because some conversation have more words to it, more chattiness. But in average, what I observed is that a conversation was around, like 1 hour of conversation was around 8,000 tokens. So what I would need to do is to just break it down into small chunks, like half an hour would already be about 4,000 tokens. So I would need to be a little clever and break it down into at least 3 chunks in order to be able to do a summary. But then what happens is that you have different approaches in order to do that. You can use the refine method, which I'll just mention in a moment, which is the one that I've implemented in the app, or you could do MapReduce. So MapReduce is essentially breaking down your document, like for instance here, an hour long of conversation, into 4 different chunks and summarize each of the sections, essentially. And then once you have several summaries, then you summarize the summaries. So this could be working. That's quite performant in terms of, because it could be parallelized. So in terms of speed of the response, you can have a fairly quick response. You can parallelize all of the summaries and then just get this final summary once all of those summaries are done. So that is one method. But you may be also losing some information when you do that, because essentially some of the context might be in one of the sections, some of the context might be in another section, and so it might not work so ideally to do such a thing. Something that I've seen being more efficient and more relevant when it comes to a long conversation about the same topic is to do essentially a refine method. And this is what I've been implementing in the app. So first you do a first summary. So it's a sequential method. You do a first summary of the first chunk. Then you go to the second chunk and you're like, okay, you're going to take the summary of the first one plus the second chunk and you're going to refine it. And you're going to iterate like this over and over again until you're done with the final summary. So this method has the disadvantage is that it's taking slightly longer, but the results might be more precise in terms of summarizing. And this is you need to remember that this isn't an exact science right now. It's more of an art. So I would engage you to try different methods and see how this is working. So this was for chaining for the case of summarization, and this was the very first application that I've used it for. There's another type of application that lends itself quite nicely to chaining, and it's Q&A. So Q&A, you can also do chaining and do map pre-rank to just try to ask the question to each of the chunk of the conversation. If you have a certain question about about a book or about an hour-long conversation, you can just break it down and say, hey, for each of the chunks, the section, you'll be like, do you have the answer to my question? And what do you think the answer is? And then you rank at the end the best answer that you think you have for each of the chunks. So let's try to do this example, and it's another bot that I'm calling Ragu. You'll see in a moment why I gave it this strange name. So here I'm going to be asking a question about the book. And the book is about 140 pages long, so it's not going to fit nicely into a context. So let's see. I'm going to ask it what are agents. So we've seen just in the beginning of this lesson the definition of an agent, and here essentially, okay, so system or framework in the context of artificial intelligence. So it's clever. It's getting the context of what I'm asking, and you'll see why in a moment. And it knows that I'm talking about language modeling, that it's not any type of agent, right? So let's see. So for instance, if asked about the CEO of Twitter, an agent may choose a search tool to find the most current information. All right, while it may opt for a computational tool to resolve a mathematical question. Interesting. Does it ring a bell? You remember that was some of the examples that I had taken in my book. And guess what? The reason for that is that it was taking some of the pages of the book as a reference in order to answer the question. So what is essentially happening here is first there's a search inside of the book, and it's selecting the pages that are seemingly the most relevant in order to answer this question. And then what it is doing is stuffing all of this context inside of a prompt in order to say, this is the question, those are the context and the reference, please answer the question now. And this concept is called retrieval augmented generation. So I'll show you a diagram that illustrates this notion. So retrieval augmented generation is the notion of taking a query, performing a retrieval on a database, a dataset of documents, enhancing this question with the retrieved documents in order to finally formulate the question to the LLM and then getting the answer. So this is a concept that is being implemented inside of this agent, and for this it's using the notion of vector search. So let's now speak a little bit about vector search and why we don't simply do traditional keyword search. In this case, so I'm going to have to tell you a little bit more about the notion of a vector search and how it's being implemented. So in order to illustrate the notion of vector search, let's just go to the relevant chapter on that topic. And before we introduce vector search, we'll simply look at a traditional search approach. So, for instance, here you have a question that could be like, who is the CEO of Twitter? And, well, this is something that is very much an information bound in time, right? In this case, with some of the earlier version of ChatGPT, the knowledge cutout of the training dataset was from September 2021. And this information, this fact here has been changing quite a bit over time. So if you were to ask ChatGPT, we didn't get it right. And that is one of the infamous limitation of language model as compared to traditional search engine like Google. So now if you ask Google, it would say, hey, who's the CEO of Twitter? And it would guess or find, based on information found on the internet, who's the current CEO of Twitter, Linda. And in order to do that, again, if you would want to trust an agent to do that, you wouldn't simply rely on its knowledge base, how it has been trained, but if it is about a current event, you would ask it to enhance, augment essentially this knowledge by using tools. And search is one of those. So you could use traditional search and say, hey, I'm going to do a Google search, so I'm going to give this agent the ability to search the web. So this is the simplest way to do that, and that's how I've implemented it, by just simply searching and getting back the response of the first page and maybe just reading the few the top articles on the page. So you can do that, making sure that you don't stuff too much content inside of the context window, or you could do what is known as vector search. And this concept is essentially another type of search, which is searching not for keywords, but for semantically similar documents. For you to understand what does it mean to be semantically similar, it's important to understand the notion of how essentially information is encoded inside of language models. So you may have heard about the notion of a token already. We mentioned, okay, we will break down the information, each of the word as token, but then what you end up with is a very long dictionary of each of the words that may appear in a sentence, and then you're just going to be recording this word as one out of the length of the dictionary. So for GPT-4, I think the length of the dictionary is roughly 100,000. So you have 100,000 tokens that can be encoded in order to ask a question to ChatGPT. This is not dense enough, and it's going to make it difficult to search efficiently inside of a large knowledge base. And this is just for words. So you can do this for words, but you can also do this for a full sentence. Okay, so or a full article, and this is when it comes to the notion of embedding. So you're going from words to vector, and then you're going to try to have a dense representation of those vectors to represent the semantic meaning of textual information. So here is a very simple app that I can show you. I mean, it's just a representation, but it's pretty cool. So let's just go and look it up. It's an article that you can check online about mapping the embeddings in 3 dimensions. So embeddings are typically in a much higher dimension, like thousands of dimensions, but we cannot quite see in a 1,000 dimension. So what we'll do here instead is just look it up in 3 dimensions. 3D is already quite useful to look at things. And here we can look at the semantic similarity of different topics coming out of the Star Wars fantasy ecosystem. So here you have some things about, okay, investment opportunity in Tibana, gas mining, it's about business and trade. Here you have galactic politics, trade disputes. So you can see how those different phrases have been essentially grouped, clustered into different topics that are semantically similar, or belonging to the same category. So this is what's happening here. And essentially, if you were to ask a question about, let's say, the politics in Star Wars, about Palpatine, for instance, like, is he a member of your Republic, then it may end up in this cluster. And so what would then happen is that you would just try to find similar things if you were to ask a question, and then look for the resources that you may have close to this request that could be found in the same space. And those things, you'll take them and you'll fit it into the context so that you can have a response that is semantically intelligent, so to say. So I'll tell you more about embeddings probably in a future lesson, but I just wanted to cover a few things like this in order to show you how you can implement different types of agents. So this was it for this lecture. You've seen a lot of different things when it comes to agents, and you've seen the notion of chaining. You've seen the notion of using tools such as search and vector search. You've seen how you can do retrieval augmented generation by chaining, and how you can use other types of tools such as Google search, or maybe the Python interpreter in the case of here your nice little friend Cody, where you can ask, for instance, the 42nd element of the Fibonacci tree, something that you definitely would not want to do simply by trying to remember it. And in this case here, okay, it's going to find the 42nd element. It's going to calculate it. Give me the code now. So here is the code for this 32nd. You can also ask, okay, what is the 10th element? Now you're going to ask for us follow-up questions. This is the code, it's completed, and here you go. It's 55. So it's just generating code, executing it. You can also ask it for nice things like, okay, here in this case, it's also going to be able to plot things. So I'm not sure that it will be able to generate a map for us, but at least it can generate a graphic. And here we go. You have a nice plot. Maybe you can just zoom in here from -1 to 1, changing the zoom. Here we go. So this was it. I hope you've been having fun. You can play around with those little GPTs and discover a little more about how to program your own GPT. Thank you so much, and I'll see you in another video.